Question 1. Two horizontal forces P and Q act at the origin of rectangular coordinates. The components of P in the x and y direction are 14 newtons and 5 newtons respectively. The components of Q in the x and y directions are -9 newtons and 7 newtons respectively. Part 1 says write down the components in the x and y directions of the resultant of P and Q. The first thing I want to do is write down vectors that represent P and Q. So I'm going to say P is this vector here, so 14 newtons and 5 newtons in the x and y. So I'm going to write 14, 5. And Q is this vector here. It's -9 in the x direction, 7 in the y direction, so -9, 7. And my resultant vector is going to be these two vectors added together. So 14, 5 plus -9, 7. And the rule for adding two column vectors is just to add the individual components. So I've got 14 plus -9, that's going to give me 5. And 5 plus 7 is 12. So my resultant vector is 5, 12. If I want to be really specific, I could say the component in the x direction is 5 and the component in the y direction is 12 newtons. Part 2 says, hence find the magnitude of this resultant and the angle the resultant makes with the positive x-axis. So remember, we worked out our resultant vector in part 1 and it was 5, 12. So let's draw a diagram to represent that. So this 5 represents a vector that's going 5 in the x direction. The 12 represents a vector that is going 12 in the y direction. Both are positive, so that's right and up. And my resultant vector is one that goes from the beginning here to the end. So this is R, this is 5, and this is 12. This is a right angle in here, and this angle here is the angle that the resultant makes with the positive x-axis. So I'll call that theta. So we just need to use some basic trigonometry now. And we can say that r squared equals 5 squared plus 12 squared, just using Pythagoras there, which gives us 169. And so r is going to be square root of 169, and it's going to be 13 newtons. So that's the magnitude of the resultant. Next, we're going to find the angle that it makes with the axis. So, if we think about basic trig rules here, we've got the opposite and the adjacent that we know, and that's going to be tan. So we can say that tan theta equals opposite over adjacent, which is 12 over 5. So theta is going to be inverse tan of 12 over 5. So let's put that into our calculator. Being as it's the first question in the exam, make sure that your calculator's in degrees mode. And we're going to do inverse tan of 12 over 5. And that gives us 67.4 if we do it to 3 significant figures. So 67.4 degrees. So we've got our resultant magnitude and the angle it makes with the x-axis.